In the profound stillness of the deep, where darkness blankets an alien world beneath the ocean's surface, a singular question emerges. We have charted distant planets with unprecedented detail, yet the vast, intricate terrain of our own ocean floor remains largely uncharted. As the camera ascends from a silent, black abyss into a dramatic cascade of bioluminescent pulses that reveal the shape of underwater mountains and valleys, the voiceover intones, "We've mapped the surface of Mars, but not the depths of our own planet. Why?" This cinematic introduction presents a stark reality. Although oceans envelop more than 70% of Earth's surface, comprehensive mapping has reached less than 20% of the ocean floor, descending into the heart of the mystery. We enter a world defined by extreme depths and complex terrain. Here, nature has sculpted underwater landscapes that rival any terrestrial formation. Consider the Mariana Trench, a seemingly endless chasm plunging over 11,000 meters deep. Advanced 3D animated maps reveal a topography filled with towering underwater ridges, steep valleys, and sprawling abyssal plains. These virtual models expose a terrain that is as diverse as it is deep. Underwater mountains rise abruptly from the ocean floor, and canyons snake through coral labyrinths, challenging the imagination even for those well-versed in the art of scientific exploration. The precision afforded by advanced sonar imaging makes it possible to visualize these monumental structures. And yet, even with such precision, the vast expanse and inherent variability of the seafloor continue to outpace our technological capabilities. Beneath these mesmerizing landscapes lies an environment where physics becomes a formidable adversary. In the crushing pressure of the deep sea, even the most robust materials yield. As we transition to exploring this segment, the narrative focuses on the harsh conditions that define the abyss. At depths exceeding several kilometers, pressure mounts to levels that can surpass 100 atmospheres, conditions that would easily deform conventional submersible designs. Here, specialized vessels like those engineered for the Challenger Deep are marvels of innovation, employing advanced alloys and meticulously engineered hull structures to withstand pressures that would otherwise reduce man-made constructs to mere fragments of failed technology. Every inch of these deep-diving vessels is crafted with precision, where even microscopic flaws can result in catastrophic failure. This remarkable balance between human ingenuity and the unforgiving forces of nature underscores the tremendous engineering challenges that remain at the cutting edge of oceanic exploration. Yet beyond the physical barriers imposed by nature, the exploration of the ocean floor is further impeded by significant limitations in our technological and financial resources. The process of sonar mapping, which relies on sending sound waves into the depths and measuring the echoes that return, is both painstakingly slow and prohibitively expensive. In contrast to space exploration, where annual budgets in the billions propel aggressive missions and satellite deployments, ocean mapping projects often operate under constrained funding. Detailed comparison charts reveal that while space exploration budgets frequently exceed tens of billions of dollars, deep-sea exploration commands only a fraction of that amount. The economics of exploration are a stark reminder that funding priorities have long favored the cosmos over the cryptic and intricate seascapes that lie hidden beneath our oceans. The disparity in investment is further compounded by the technical challenges. Each sonar sweep covers only a limited swath of the seabed, necessitating years, if not decades, of cumulative effort to assemble a complete picture. Compounding these challenges is the profound darkness that envelops the deep ocean. Beyond the reach of sunlight, at depths typically greater than 1,000 meters, an eternal night reigns supreme. In this realm, the familiar warmth of the sun is replaced by an environment where darkness stifles traditional methods of visual exploration. Without natural light, scientists must rely on artificial illumination and, more critically, acoustic methodologies such as sonar to illuminate the unseen. Advanced animations illustrate how sound waves propagate through seawater, with frequencies carefully tuned to bounce off topographical features and return echoes that can be translated into detailed images of the underwater landscape. The reliance on sound over light is not merely a substitution, but a sophisticated adaptation to a unique set of challenges, as sound travels more efficiently in water. Despite these adaptations, the inherent limitations of sonar resolution compared to high-definition visual imaging mean that many of the finer details of the seafloor remain shrouded in uncertainty. Amid this dark, pressure-laden environment thrives a host of life forms that have adapted in astonishing ways to survive where few organisms dare to venture. Deep-sea expeditions, though limited in scope, have revealed ecosystems populated by mysterious and enigmatic creatures. Bioluminescent organisms, in particular, serve as a beacon of wonder in an otherwise opaque world. These luminous beings have evolved intricate biochemical processes to produce light, a trait that is both a survival mechanism and an evolutionary marvel. In the inky depths, where energy is scarce and conditions are extreme, bioluminescence provides critical advantages such as predation, mating signals, and camouflage, an adaptation that continues to capture the imagination of marine biologists and technologists alike. Detailed analyses of genetic material extracted from deep-sea samples have further revealed that many of these organisms possess unique adaptations at the cellular level, offering insights into evolutionary processes that diverge significantly from their shallow water descendants. This segment reminds us that the ocean floor is not merely an inert landscape of rock and sediment, but a dynamic, living system with ecosystems that remain among the least understood on our planet. As the narrative transitions towards its reflective conclusion, the cinematic visuals shift once more, from the deep, oppressive darkness to the gentle, welcoming glow of a sunset over the ocean's surface. In this final segment, the narrator invites us to contemplate the vast, uncharted territories of the deep sea. Hovering over panoramic shots of ephemeral light dancing on gentle waves, the observer ponders the profound mysteries that lie hidden beneath. The ocean floor, with its labyrinth of trenches, ridges, and volcanic ridges, holds secrets that span epochs, a record of Earth's geological evolution and the unyielding persistence of life under the most extreme conditions. The imagery is both awe-inspiring and melancholic, underscoring the duality of human endeavor, our relentless pursuit of knowledge, and the humbling realization that our planet still harbors realms that defy easy understanding. In the hushed whispers of this submerged world, where every crevice and canyon holds tales of ancient tectonic shifts and evolutionary breakthroughs, there emerges a clear message. The limitations of our current technology and funding paradigms have left vast portions of the ocean floor shrouded in mystery. The challenges are multidimensional, rooted in the fundamental laws of physics, compounded by economic priorities, and masked by the natural obscuration of light. Each increment of progress in deep-sea mapping reveals new questions, even as old ones persist, driving home the point that exploration is as much about uncovering our planet's past as it is about charting a future where these hidden kingdoms might one day be understood in their entirety. Throughout this journey, advanced computational models and enhanced imaging techniques have provided us with striking representations of the underwater world. Yet even these technological marvels underscore a sobering truth. Our current capabilities, while impressive, are still outstripped by the sheer scale and complexity of the Earth's final frontier. The interplay between fragile, high-tech tools and the relentless pressures of nature creates a delicate balance, one that demands not only technological innovation, but also a re-examination of how we value and invest in the exploration of our own planet. The sheer expanse of unexplored seafloor, laden with unknown geological features, untapped biological wealth, and historical narratives embedded in the very fabric of the Earth, provokes a mixture of scientific determination and philosophical wonder. The hidden depths challenge us to think beyond the immediate allure of space exploration, to recognize that true understanding of our world entails a comprehensive study of both skies and seas. As the narrative draws to a close, the concluding imagery of the sun dipping behind the horizon over a calm, shimmering sea reiterates the central thesis. The ocean floor holds secrets older than time, and despite decades of inquiry, humanity has only just begun to listen to its silent stories. The final aesthetic touches, a series of slowly fading visuals accompanied by reflective voiceover, pose a compelling inquiry, inviting viewers to envision the future of deep-sea exploration. What will we find when we finally reach the bottom? The screen seems to ask. A call to arms for continued curiosity and relentless pursuit of the unknown. In this cinematic exploration, the narrative has traversed the staggering depths of our oceans, illuminated the innovative engineering that allows us to reach these extreme environments, and highlighted the delicate interplay of funding, technology, and natural challenges that together impede our full understanding of Earth's submerged terrains. Each frame, each carefully rendered animation, and each meticulously researched data point serves as a reminder that our planet's greatest mysteries remain not among the stars, but beneath the waves. This journey through realms of crushing pressure, impenetrable darkness, and enigmatic ecosystems reveals not only the formidable obstacles of deep-sea exploration, but also the boundless potential for discovery. Advanced sonar systems, high-resolution bathymetric mapping, and pioneering submersible designs stand as testaments to the indomitable spirit of scientific inquiry. Each technological breakthrough opens new avenues for understanding the geological history, biological diversity, and environmental dynamics of the oceanic abyss. As we rely increasingly on these sophisticated instruments, our collective endeavor continues to bridge the gap between imagination and empirical knowledge. Standing at the intersection of scientific innovation and natural wonder, we are reminded that the story of our planet is not solely written on its surface, but also etched into the very contours of its ocean floors. The meticulous work of marine geologists and oceanographers, tirelessly piecing together signals from the deep, underscores a profound truth. Understanding our world requires comprehensive, persistent inquiry into every hidden corner of the earth. The narrative, imbued with both technical rigor and a sense of poetic mystery, calls on experts and enthusiasts alike to consider that beneath the serene, sunlit waves lies a realm fraught with challenges, infinite complexity, and stories waiting to be told. As we leave the depths and return to the surface, where the day meets the night in a dazzling display of color and light, the inquiry lingers in the mind like the soft ripple of the ocean against the shore. The ocean floor, with all its hidden wonders and unwavering mysteries, remains a frontier as vast and compelling as any space yet to be fully mapped. Though our technological reach has extended in leaps and bounds, the laboratory of the deep continues to defy simple explanation, urging further exploration through innovation, collaboration, and determination. Thus, immersed in the splendor and enigma of our planet's final frontier, we are left with both answers and profound questions. The story of the ocean floor is one of extreme depth, relentless pressure, and hidden beauty, a narrative that continues to unfold as we strive for a deeper understanding of the mysteries that lie beneath it. And in striving for that understanding, we not only push the boundaries of science, but also rekindle an age-old sense of wonder at the immense complexities of the natural world. What will we find when we finally reach the bottom?